So this is 2016 A level part B, question number 1, right? So first of all, we have given values K1, K2, K3, and then we have a lock. So this is what we have. We have to use exactly the same symbols. So this is 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are the inputs, 3 inputs, and according to the description given, uh, to make the lock, at least any two of this should be true. So which means this will be 0, this will be 0, this is 0, but this is 1. So here we have 1 is 0, then we have 1, 1, 1. So the equation by looking at sum of products, so that means we have to consider only ones here. So we can write the Boolean expression L as, we can say, first one is K1 bar, right? Into K2, K3, we have K2, K3 plus, we have next one is here, we have K1, K2 bar 3, K1, K2 bar, K3 plus, then we have the next one, that is K1, K2, and then we have K3 bar plus K1, K2, K3. From the Boolean expressions, now we have to solve this, isn't it? So you can look at like what to put them together. So there are no unique values, but if you look at the first term and this term, we can put this, isn't it? So that means we can combine, yes, this term with this. Why is that? Right? Why is that? Because there are two symbols are the same, K2, K3. We know from the Boolean rules that A is plus A equals A, which means A equal A plus A. So you can multiply. So you can have multiple terms to solve this with other 3 terms. So which means we can rewrite this expression saying that K1 bar, K2, K3, and then I will take one of these terms. So that means K1, K2, K3. So that's the first one, plus. I'll take the second term as well. You can simplify with this one. So we will have K1, K2 bar, K3, plus I'll take one term from here. So K1, K2, K3, plus we have the last term, this one. So that is K1, K2, K3 bar plus K1, K2, and K3. Now, if you look at this first two terms, we will see K2, K3 is common. So we will take out K2, K3. If you take that out, we will have K1 bar plus K1. right? Plus, if you take the next two terms, K1, K3 common, K1, K3, we have K2 bar plus K2 plus, if you take the last two terms, that is K1, K2 is common. So we can say K1, K2 into we have K3 bar plus K3. From the theory, we know that A plus A bar equals 1. So this will be 1. So this is 1. This is also 1. This is also 1. So which means now we can put the answers K1 into K2 plus K2 plus K2 K3 plus K1 into K3. Yes. So this is the answer.
So to construct the circuit, we have been given 6 NAND gates and 1 OR gate. Now let's see how we could construct this. Okay, we have been given NAND gate to construct this. If you take NAND gate, what is NAND? Let's say you have A and B. What is output? Let's say Q. Output is A dot B bar. Now what we need is K1 and K2, right? Okay, now let's see how to put this in using NAND gates, 6 NAND gates and a 1 OR gate. Now for this, first of all, we'll look at NAND gate. Now if you look at the NAND gate, so we want to make K1 and K2. Let's look at only this part. So which means we know that if you put one side K1 and the other side K2, then what you will get is K1 dot K2 bar. Yes. But then there's a question like how we are going to convert K1 K2 bar into K1 K2. It's like one side we have K1 K2 bar. Now for let's say this is A, right? So let me remove, instead of K1 K2 I will take A. So let's say A bar, we want to make it A. Now for this gate, you know that you have to put a NOT gate, but unfortunately we have not been given any NOT gates. What we have is, yes, NAND gate. How do you convert NAND gate into a, yes, NAND gate into a NOT gate? So that's the question. So let's say we have like this. The simple solution would be like instead of putting, I'm going to use the same value, which means I am going to take the 2 and then I'm going to connect with, let's say, A. What will happen? You have A here, A here. The output of NAND gate is A dot A bar, which means A bar. So now you know that what to do. So in this particular case, you can get this now to make it K2. So you connect another NAND gate, which we will convert this to K1, K2, right? So this is exactly what we are going to do here. Now let's say, we'll draw everything now completely. Yes, I'm going to get 3 lines to represent K1, K2 and K3. Yes, I'm going to get K1, K2 and K3. So let's say I have in lines, and then so K1, K2, first one is K1, K2, I will take K1 and this is K2, right? So this is NAND gate. And to make it K1, K2, we have to combine another NAND gate, right? So that's exactly what we have discussed. So another NAND gate we need. Then K2, K3. So we need K2, then K3, we need one NAND gate. Yes. So for that, again, I'm going to connect another NAND. Yes. Then we have K1, K3. So we have K1 and then K3, another NAND gate. Yes. And then we will connect NAND gate here as well. So now we are getting from here, we will get K1, K2, here K2, K3, and then K1, K3. So then we can use O gate. Now let's look at the O gate. We will put the O gate. Yes. We'll put everything. And then the output will be L. Okay. Okay. So 2017 part B question number 1. When you simplify, we have to have B C bar. Now for this, we have to use the De Morgan's rule. We know that to get x plus y bar, you have to have x bar dot y bar. So which if I take it as x bar dot y bar, we equate these two. X bar equals b, and then that means x is b bar and y equals c. So that means if we have b bar and c, put it to a NOR gate, we are getting the answer. So which means to make it a b bar, from b we know that you can short circuit NOR gate like this, and then the answer is b bar, and from side we will get c. We combine, we get the output. So what we have got, BC bar AC, so AC plus B C bar only.
C bar.
Yes, that's what we need. Now to get this, what we have is NAND gates. But we have NAND gates. So if you have AB, NAND means A dot B bar. Now, like in earlier, you have to make it. Like, how do you make it? A dot B bar. So the one idea would be, we'll take this. Now what we have is AC plus BC bar. Put two double, make two double bar. The idea is here is we want to make it a multiplication. Now to make it a multiplication, so I'm putting two double bars. Now from De Morgan's theorem, we know that x plus y bar is equals to x bar dot y bar. So I'm going to use the same here. I will take one bar and remove the rest. So that means I'll take the one bar as it is. And then I have AC plus BC bar. I will apply De Morgan's rule. You can say, okay, so this is equals to AC bar dot BC bar. Got the point? We can draw the circuit. Now we will have A, we have B, we have C. First of all, let's AC bar. How do you make AC bar? You put a NAND gate, you get A, B, here C. So I will put a bar A and C. So this will give us AC bar. Next, what I have? I have to have BC bar, but first of all, I need C bar. Now to get a C bar, right, get a C bar, I will take a NAND gate. Now I'm getting a C bar. Now this is C bar and B. So we need B. So we get a B here. Put another NAND gate. Now from here we will get AC bar. From here we will get BC bar. So BC bar. So both of them we can put into another NAND gate. So this is called set.